On August 16, 1945, humanity completed the first actual combat use of a nuclear bomb, witnessing the immense destructive power of nuclear weapons. People also realized the significant impact of nuclear bomb explosions on the bombers that dropped them. According to the B-29 crew member Tibbets, the aircraft seemed to have been hit by anti-aircraft fire, and the aircraft was exposed to intense light. Since then, people have increasingly focused on protecting bomber crews and have developed many specialized devices to protect them from radiation, intense light, and other effects. The shock wave, radiation, and intense light produced by a nuclear bomb explosion can cause enormous harm. Intense light in particular can cause temporary blindness, lasting about 2 minutes during the day and about 10 minutes at night. The early protective equipment was simple, such as protective goggles. The U.S. military began using a device called thermal curtains on the B-52 bomber. This device looks similar to the sunshades used in cars, but is more complex. The thermal curtains are additional equipment issued to the Air Force. They are normally packed and stored, and a set weighs about 30 pounds. If the bomber needs to carry out a nuclear bombing mission, it will be brought on board. The individual curtain is 40-50 inches long and 30 inches high, with a thickness of about 2.5 millimeters, consisting of 3 layers of materials, including a reflective layer, a reinforcing layer, and a rubberized vinyl cloth. The bomber needs to install cameras and imaging devices, because when the windows are completely covered, the crew cannot directly observe the outside. A set of thermal curtains costs $2,500 and can protect the crew from intense light. However, its protection against nuclear explosions is not very effective, so the U.S. military mostly uses it for training, typically twice a year. However, in reality, crews and maintenance personnel often use it as a sunshade during hot seasons, causing wear and aging of the equipment. The Air Force has to purchase additional fabric sunshade equipment at a cost of $300 per set, hoping that the crews won't misuse these expensive thermal curtains. The U.S. once used a protective device integrated with the cockpit on the A-4 Skyhawk attack aircraft. This radiation protection and heat-insulating cover is similar to a sunshade on a stroller. In daily use, it folds backward to the rear of the cockpit and extends forward to semi-enclose the pilot when in use. It effectively prevents radiation and intense heat from harming the pilot and allows the pilot to maintain basic flying capabilities while keeping an eye on the instrument panel. This equipment was deployed on aircraft carriers along with nuclear bombs, indicating that it is one of the components of the carrier battle group's tactical nuclear deterrence. However, due to its large size and limited flexibility, it is not very easy to use. In the 1980s, the U.S. began using another type of protective equipment, introducing polarized zirconium titanate lead, PLZT, into the helmet as protective goggles. This type of protective goggles is a composite material, with the innermost layer being a transparent electro-optical ceramic. When an electric current is applied, it becomes transparent to ensure normal vision. The sensing element of the device immediately shuts off when it detects the flash of a nuclear bomb explosion, causing the lens to darken and protect the pilot. The benefit of this device is that it is lightweight, flexible, and instantly effective. Pilots do not need to manually activate certain switches. The device automatically responds to the external environment and can also react to lightning. Its downside is that during the flash, the pilot is completely blinded. However, this is not a major problem on modern aircraft. Firstly, the duration of the flash is short, and secondly, modern aircraft generally have reliable autopilot systems to assist the pilots in stabilizing the aircraft. It is said that the B-2 stealth bomber can also have an additional glass panel with the same function installed on the dashboard. The U.S. also experimented with integrating this protective device into the entire cockpit canopy. However, it was found that as the area increased, the response time of the equipment slowed, and the crew inside would still be affected by intense light, making it not as quick as the helmet-based response. The helmets with PLZT protective goggles are disposable, and the crew receives a small amount of simulation training each year. Some might wonder why such convenient protective equipment is not mass-produced and equipped for the crews of other aircraft. The reason is simple. Senior officials believe that in a nuclear war scenario, these personnel cannot effectively survive, and it is not necessary to wear such expensive equipment.